Assalamualaikum warahmatullahi wabarakatuh. Today I will discuss about the H-bridge. First of all, my remember the Allah Salam Kalhama Ismi and saying Malik Mosul Al Kazmi, the overview of this H-bridge circuit. The object of the project is to design and implement a BJT controlled J-Fed H-bridge circuit with the capability of controlling whichever direction of the DC motor or our choice we rotate, also known as bidirectional control. Both directions of the operation for the motor are controlled by two switches. The switches that we use can control the directions of the motor, acting in conjunction to achieve the object, and by that it can understood that if both switches are turned either on or off, the DC motor should not achieve. In contrast, if either of the switch are on or the other is off, then the circuit should function in a predictable manner under the parameters set by the designers. In addition, it has been required that the motor runs at 9 volts and draw a maximum current of 2 amps. We made a short video on the working of this HBridge in which we apply 9 volts in the input and we will gain 2 milliamps and the motor will run. We will show this video later on. With that, it is also mandatory for us to implement the functionality of an optocoupler within the circuit and integrated by the diodes. Basically, optocoupler is basically provides the path. It has two sides, input and output. In input side, it has a photodiode. It has LED, and in output side, it has a diode. As the current passes through the input side, the LED blinks up and the photodiode detects the light and it behaves as a conductor. In this way, the optocoupler works. In our project, we use this PC817 optocoupler. The following concept will provide the detailed description and analysis of our H-bridge bidirectional motor control using BJT as a switch. Material that we have required for this is DC motor that we have used at our output, rectifiers, voltage regulators, resistors, capacitors, transistors. In this we use 4 NPN transistors and diodes. The diode is used for flyback diodes, clean PCB connecting wires, heat sink, power supply and oscilloscope. Working principle. This is basically the two circuits that explain the working principle of this H-bridge. This is called H-bridge because of its shape. As we can see, this is a H shape, so we call this as H-bridge. In this we apply input side. In first circuit we apply input and Q1 and Q4 is on and the current flows through that direction and the motor moves in this direction in clockwise. Then if Q1 and Q4 is off, then the current flows from Q1, then motor and then Q2 and then grounded. So here we explain this. If Q1 is on and Q2 is off, Q3 is off and Q4 is off, the direction is clockwise, as we have seen in this diagram. If this Q1 is off, Q2 and Q3 is on, Q3 is counterclockwise. Otherwise, it will be 0. In case 1, Q1 or plus Q4, according to the data sheet of each of the transistors, that it is extended and active, a particular amount of base current must be provided to the transistor to allow the current in the motor. For either combination, one has a high signal activating the transistor as known as on state, while the other two transistors will have the lower signal and therefore they will be on 0 off state. In case 2, visualizing a mirror design on each side of the circuit. If all transistors were enabled, high signals would meet at the center where the motor is cancelling each other out and rendering the circuit inactive. If they are 0, then the optocoupler is in charge the supply current to the transistor in order for activating do not receive current, meaning the full transistor does not turn on. In addition to the flyback diodes, because the high voltage rises across the transistors when they are instantly running on and off, generating heat within the terminals and reducing its functionality in a long term. This high voltage that generated is called the back EMF or flyback voltage, and therefore the diodes are called the flyback diodes. Basically, in this circuit we uses 4 flyback diodes to reduce the back EMF or flyback voltage. When BJT is crucial to have the operation in conjunction so that the dual PNP is placed in the upper half of the will explain later. With both NPNs and PNPs, the emitter current IE is the sum of collector current IC and the base current IB and IE equal to IB plus IC. However, in case of NPN, the emitter emits current and the collector base receives the current. PNPs collect current from either emitter or distributed current within the emitter and base. So, why this is a block description. The block diagram simply portrays the order of the functionality of the circuit, starting with the activation or supply of the battery, which in turn is allowed by way of push buttons present in its path. Following the activation of the supply, realization its path throughout the HV and in consequence passes through the motor, which also activates in accordance with the level of supply. By the block diagram, battery then power supply to the HV with refining, braking, and then the motor. DC motor. The original design comprehensive for a motor of a high voltage or require resistance allows a minimal current to pass through the BJT and in return activated the motor. This specific motor with an nominated voltage of 6, high torque and a high RPM rotation per minute of the approximately 9000 was relatively easy to activate, and even a current of 36.6 milliamps passing through it was enough to power it to a voltage of 10. The advantages of using TIP transistor tip 31 transistor was fully explored when the required adjustment was made to accommodate the supply for the lower coil resistance motor, in contrast with the specific motor having approximately 1000 RPM. We explain this now. Rectifiers, the working of rectifiers. The rectifier is an electrical device that converts the AC into the DC, typically used when you are constructing a circuit with components that require this transformation in order to function to avoid the damage. Its formation is comparable to one-way valve, which only allows current to on in one direction, thereby converting AC current to DC. Basically, DC is an alternating current and it follows to the upper half and the negative half, and it converts to the DC, which gives them a single path. In this specific circuit, we have not implemented a circuit device of any kind of voltage regulator. Voltage regulator is a measurable of the sustainable to of a secondary output supplied by the power transformer when it receives a constant primary supply voltage. It is measured in percentage and lower it generate more output. This is our systematic circuit. Here we use optocouplers, resistors, 4 resistors, 4 NPN transistors, 2 optocouplers, and 2 1K resistors, and then the power supplies. First of all, the power supply is connected to the first of the optocoupler. It connects to the LED that blinks up the LED, and in the output side of the autocoupler there is a photo detector that detects the light, and the autocoupler becomes the conductor. Here the second terminal is grounded. From this fourth we give the signal to the fourth, and from to the resistor, and the signal is given by this. If this owns this circuit is connected by this first autocoupler, and this autocoupler is connected. If current is through to this, then Q1 and Q4 is on. If current flows through this circuit, then Q2 and Q3 is on. In this way, how it works. The calculations, we do some calculations on this. A PCB process design systematic according to the datasheet of the each component present within the configuration. Test configuration on breadboard. Design PCB in accordance with the functionality systematic along with the specification optimization. Gather prints and implement the design on the board to remove excess copper. Place the imprinted board into the boil of boiling water and pour FeCl3 into it. Once the excess copper is removed, clear out in the neat copper pathways by applying trace amount of petrol over the layer of the wiping it off. Proceed to drill the terminals of all the components using a drilling machine. Patch the circuit according to the design. Solder the component on the breadboard. Test the circuit and examine results or errors when using DMM. This is the PCB design. This is in 3D. This is the real project after the completion of our circuit. So we have this motor, 4 T blocks, 4 NPN transistors, 4 flyback diodes, 4 330 ohm resistors, and 2 1K resistors. Here this T block we uses the switches. From this we given the power supply, and this T block is for the output, that is for motor.